Hi guys, welcome to Mr. Robeson's AP Statistics class. Today we're going to go over the difference between taking samples and doing a census, and we're going to go over 6 different sampling techniques. Alright, so first off, what is a census? Well, a census is when we ask everybody in the entire population what they think about something, or we use everybody in the entire population for part of our experiment. All right, so you may have heard this in the news recently because the US does a census every 10 years to count everybody in the entire country. All right, that's why it's called a census, because we're doing everyone in our entire population, the entire population of the US. All right, but we can also do a census with everybody at our school or everybody in our classroom if we're only concerned about people in our class, or everybody in Oakland or everybody in California. All right, so the pros with this is that we should know exactly what the entire population thinks or how it reacts to something without having to do inference techniques. So we don't know what inference techniques are yet, but we will have those later on, and those will be helpful, but it is work sometimes. So if we can ask everybody, then we already know and we don't have to do any other sort of stuff. The cons here, you know what, sometimes it's really hard to ask everybody. So if we want to ask everybody in the United States a question, that's 320 plus million people. Everybody in California, still millions of people. Everybody in Oakland, that's about 500,000 people. So a census can be very difficult to do, especially if you're only one researcher. All right, and mistakes will happen. All right, so if you're doing something a million times, chances are there's going to be a few mistakes. So even if you do sample everybody doing a census, it's still not going to be perfect information. All right, and if you don't believe me, let's try this little experiment here. All right, so we are going to do a census here. This is a frog fairy tale. So there's a nice little story here. It's just the bottom of the slide. It is decently long, not super exciting. It's about frogs. All right, but there are several G's, lowercase or capital G's. And what you're going to do is just read the story and count how many G's you come across, lowercase or capital. All right, since you are able to count from every word in the story, this is a census. All right, so now we're going to go radio silent here, and you are going to have 3 minutes to count all the G's. All right, on your mark, get set, go. And that's time. So how many G's did you count? Was it 80? How about 82? Maybe 84? Or was it 79? All right, well, when we did this 2 summers ago with a room full of about 20 AP statistics teachers, only 2 people got the correct answer. The correct answer is 83. So there were 83 G's. So you just did a census. Maybe you got all 83. Good for you. Maybe you didn't. I have a feeling most people out there did not count all 83. You either missed a couple or you added some extras or miscounted somewhere. It's difficult to do. That's the problem with the census. They are difficult to do. All right, so this is why we take samples. So a sample is just a smaller subset of the population used to gather data. So we just pick a group of people and we only ask them our question or only make them part of our experiment. And that is our sample. All right, why do we do this? Well, it's easier. Right? Interviewing 100 people is a lot easier than interviewing 3 million people. It's going to be a lot faster, a lot cheaper, and our answers are going to be just about as accurate if we do it correctly. All right, so now there are some issues that come up with samples. So one would be if we do it incorrectly or if we just get unlucky. So sampling error is when we have underrepresentation of one specific demographic. We probably also have overrepresentation of another demographic. So say we take a sample, we hope it's random, we want half men and half women or somewhere close to that, and we end up getting like 75% women from our random sample. It happens sometimes. That would be sampling error because we underrepresented the men and overrepresented the women. Another thing that can happen is called sampling variation. So different samples will have different answers because every sample is different. Every person has a different answer to things. Right? This doesn't mean you did anything wrong. It just means if you take one sample one day and take a different sample the next day, the answers you get from those 2 samples are probably going to be slightly different. And that those differences are called variations. So that is differences occurring based on using different samples. We call that sampling variation. Later on this year, we'll have ways to account for sampling variation. All right, so what are some sampling techniques? So we've got 4 good ones here: simple random samples, stratified samples, cluster samples, and systematic samples, and 2 bad ones: voluntary samples and convenient samples. All right, so a simple random sample, which we'll often just abbreviate SRS. The easiest way to do this is just to put names in a hat. All right. In past years, we've always just called this the simple random sample sombrero. All right. Alliteration, it works. They all start with that. Simple random sample sombrero. So we write all the names in the population and we put them on sheets of paper and put those pieces of paper into a hat. We then mix them up. We have to state that we mix up what's in the hat, otherwise it's wrong. And then we choose names or treatments from the hat. So we're choosing out pieces of paper from the hat, and those things that we choose will be assigned to our sample or will be assigned to some sort of treatment. If we're doing an experiment, they could get whatever drug we're testing, that sort of thing. All right. The interesting thing with simple random samples is that all samples of a certain size, like say size n, maybe n is like 20 or 50 or 100, have the same chance of being selected. All right, this is the only one that works for. So all the other ones do not have that condition. All right, so simple random sample, all samples of the same size have the same chance of being selected. We can also do simple random samples with a random number generator, but those are a little more complicated because sometimes numbers will repeat with random numbers and things like that. So your best bet is always just to stick with the hat. That is my advice to you, is stick with the simple random sample sombrero. Our next sampling method is a stratified random sample, or just a stratified sample. When a stratified sample, we break the population into related groups. So before we even take samples, before we even start selecting people, we take our population and we break them up into groups that are related in some way, like all the men in one group, all the women in another group. Or everybody with blue eyes in one group, brown eyes in another group, green eyes in another group, hazel eyes in another group. We group them with some sort of related characteristic. Then we randomly choose some from each group to be part of our sample. So we could choose, 100 men and 100 women. All right. This is an easy way to make sure we have the same number of each demographic that we're interested in studying. All right. And if we're doing a simple random sample or describing it, make sure you state who's getting assigned to do what. So strange things can happen here. So within each strata, so when we're stratifying, our groups are called strata. So within each group, there may be a simple random sample taken. So like you could have 1,000 men and you're doing a simple random sample to get 50 of them. That does not change this to a simple random sample. This is still a stratified sample because you broke it into groups first. That's just the random part of it. All right, so break it into groups first, sum from each group, stratified sample. Next one, clustered random sample, or just a cluster sample. All right, this is another good one. The population is broken up into groups that have similar or something similar to each other. All right, so the groups are all homogeneous. So one group is about the same as another group is about the same as another group. All right, and then instead of taking sum from each group, since all groups are roughly the same, they're homogeneous, we just select a couple of groups and we interview everybody in those groups. All right, and that would be a cluster sample. All right, so we're putting into groups and then we're picking all of a couple of groups. This is popular in farming. All right, the next one, systematic random sample. All right, so with a systematic random sample, we line everybody up or we put them in alphabetical order. So we take our entire population and they are in order somehow. And then we're choosing a random place to start. We can do that with a random number generator. Just throw out one random number and that's where we're going to start. Then we usually take another random number and we count, and maybe our random number was 10. Every 10th person then we select to be part of our sample, or every 5th person in line. So we just go down the line and we just pick you, no, 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 yes, no, 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 yes, no, 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 yes. And we throw them in our sample if the answer was yes. All right, the two bad examples are the voluntary sample, where people get to choose to be part of the sample. So like online surveys or TV news shows, that would be an example of a voluntary sample. Or like if you're sampling somewhere and you're just asking people to come up and fill out a survey, that's a voluntary sample. All right, that's bad because only the people that are interested in the topic are going to fill out the survey. And the other bad one is convenience sample. So that's when you go around and you ask the people that it's convenient to sample. Like if you walked out in the hallway in school and just interview the people that are walking down that hallway and nobody else because that was the easiest thing for you to do, that's not going to be a good sample because maybe if it's a math hallway, you're not going to get kids coming from other classes or having certain teachers, or you'll miss out on certain grade levels, or you'll get more guys than girls, or all sorts of bad things can happen with convenient samples, so we try to avoid them. All right, so examples of each one. So a simple random sample here, a basic example of this would be the lottery. So we take 60 balls and we put numbers on them 1 through 60. The balls are placed into this machine. This is our simple random sample sombrero as far as we're concerned. And they are mixed up. You can see they're getting mixed up right in there. And then 5 balls are randomly selected to be part of our sample. And our sample, I guess, would be the winning lottery numbers. So we're randomly selecting 5 after they're being mixed up in here. All right, so any group of 5 balls have the same probability of being selected. That's what makes this a simple random sample. Stratified random sample. So we're going to look at testing a new drug. So to test a new drug, the population is separated into men and women because the drug could have reacted differently to each gender, or each sex could react differently to the drug. From each gender, a random sample of 200 people are selected to take part in the trial. These 400 people, the 200 men and 200 women, are going to have our sample. All right, so we broke it up into 2 groups, men and women, and then we made sure to take 200 from each. So our strata for our stratified sample, our men is one strata, women is another strata, and we're taking some from each to make up our sample. That's stratified. All right, cluster. All right, so our cluster sample, the NBA in college. A researcher wants to take a sample of NBA players to ask if they thought going to college before the NBA was useful. The researcher randomly selects 3 teams and then surveys everyone on each of those teams. All right, so our clusters here, our groups are each team in the NBA. So what is there, 30 NBA teams now? And then they're randomly choosing 3. So they're breaking them up into groups that are similar, like all teams have a certain number of players on them. It should be about the same number of players. All teams have some centers and point guards and forwards and all sorts of other positions. All right. And then we're taking 3 teams and we're just interviewing everyone on those 3 teams. So everyone in those 3 groups, that is a cluster sample. All right. I think most of you have been to the airport probably some point in your life. Maybe not. So a systematic random sample is airport security would be an example. So at the airport, passengers have to line up to go through security before boarding their flights. Each morning at the airport, the TSA chooses 2 random numbers, like say 42 and 14. All right, then they start pulling people out at to be randomly checked at number 42, and then every 14th person after that is selected to be checked. So we start randomly at number 42, and then we count, and once we get to 14 people after that, that person gets selected. Then we count again. Once we get to another 14, we select that person. And all these people that are selected, that is our sample that's randomly checked for an extra security check. All right, the bad ones, the voluntary response sample. All right, so it's not ways that we want to do if we're doing actual research, but sometimes it's useful to just learn information. So Saturday mornings on CNN, there is a show called Smerconish, and each Saturday morning, the guy's name is Michael Smerconish. Smerconish is his last name. Each Saturday morning on his show, there is an online poll asking viewers to go online and respond to his question of the day. All right, those who choose to respond are part of the sample, and those who choose not to respond are not part of the sample. So it's completely voluntary if they want to be part of the sample. All right, again, this is not a good way to do a sample, since only those who feel strongly about the survey in either direction, for or against whatever the question is, are likely to go online and respond. I've probably watched this show 20 or 30 times. I think I've responded to surveys twice. All right, so it's not really the most accurate way to collect data. All right, and the last one here, convenience sample. So this is, again, another one of the bad ones. So the best team in baseball. A really bad researcher goes to an Oakland A's game, and when the game ends with an A's win, he goes to the parking lot to survey fans as to which team is the best team in baseball. Each person that he asks in that parking lot is his sample. All right, this is not a good way to take a survey. All right, because he's probably only getting Oakland A's fans, and since the team just won, everybody's going to be excited and say, yes, their team's the best team in baseball. Maybe they are, maybe they aren't, but that's not a random way to take a survey. That's not a good way to do things. All right, if you want more information, here are some links. I'll post them under the video. And for my classes, again, you've got a Sporkle quiz to do after this and a homework assignment that goes with this one. You should take notes on this presentation. You do not need to turn in the notes, but you do need to turn in the results of your Sporkle quiz. Keep doing it till you get 100%. That's what I want you to turn in. All right, tune in next time when we go over biases.